In this video, we'll be solving a question on unbiased estimators. We are given this question here to find the expectation and the variance of this. For more on this topic, you need to subscribe to this channel. Solution. If given this, the expectation of x squared 1 all over n minus 1 summation of xi minus x bar all squared, where I ranging from 1 to n, is the same thing as 1 all over n minus 1 expectation of summation of xi all over x bar all squared, which is the expected value of x. So the next thing to do, we come here, the expected value of x squared, we want to show that it's equal to the variance. It's equal to 1 all over n minus 1. And we know that this is a summation sign, so we write it as summation of the expected value of xi minus x bar all squared, which is the same thing as 1 all over n minus 1. This is sum. If you sum a constant, you get n. So we have that n expected value of xi minus x bar all squared, which is also the same thing as 1 all over n minus 1 n into xi minus n into expected value of x bar. We should also recall that the expected value of x is equal to the variance plus mu, and the expected value of x bar is equal to sigma square all over n plus mu squared. So infusing this into this, we get that the expected value of x squared is equal to 1 all over n minus 1 into n multiply this minus n into summation of s square all over n, sigma square all over n plus mu square. We can open the bracket to get 1 over n minus 1 into n sigma squared plus n mu squared minus n sigma squared all over n minus, as we are opening this bracket, to get n mu squared. So if we see, this can cancel this. Also, this can cancel this. So we are left with 1 all over n minus 1 into n sigma squared, remaining sigma, minus sigma squared, which is equal to 1 all over n minus 1. We can open the bracket to give us this, and this is common. So we have n minus 1 sigma squared. So this can cancel this. It then means that the expected value of x squared is equal to sigma squared. So this is how we can obtain